Welcome to the project demonstration of MATLAB GUI Controlled Robots along with laser shooting gun with controlling DC motor, as well as person detection with the help of PIR sensor, and also live streaming will be done with the help of this ESP32 camera. And whenever the person is detected, PIR sensor will inform to the microcontroller and then we'll get the buzzer alerts. And also we can control the robot direction forward, backward, left, right, and also laser gun position up and down. So these will be controlled from the MATLAB GUI, so which we developed, and through the code the commands will be sent with the help of the ZigBee communication module, and which is operated at 433 megahertz. So here this robot consists of a receiver module, so which is connected to on this section, and the data will be given to the microcontroller. So once the data was received, microcontroller will process that. So based on the input signal from the MATLAB GUI through the ZigBee module, we are going to controlling the robot and gun position, as well as laser directly will be on continuously. So next we also sending the video streaming with the help of this ESP8266 module. Coming to the connections, so here we are using the two L293D motor drivers, so which are used to control the 3 DC motors. Each L293D motor driver consists of dual H bridge circuit inside that. So dual H bridge is nothing but 1 H bridge for per motor. So that dual H bridge means we can control the 2 DC motors. So this robot consists of 2 DC motors for the movement, and that will be interfaced to the L293 motor driver, and this L293 motor driver connected at C0 to C3 pin. And this one is to control the gun position, as we are using 1 DC motor, so one connection will be made here, and which was connected C6 and C7, and the whole system driven by this 12 volt 1 amp battery. So it is actually a battery pack consists of 3 4 volt 1 amp batteries are connected in series, so we will get 12 volt 1 amp, and which is a rechargeable battery. So in order to recharge that battery, so this charger will be provided for you. So just provide the 230 volts input to this plug, and then the system will go on, and we need to connect the battery at the B to the B slot and already T to the T slot. Now the system is charging. It will take maximum of 8 hours to be fully charged. Once the time is completed, then you can disconnect the charger. So based on the timing only, we are going to charge this. So coming to the charging circuits. So this charging circuit consists of transformer inputs, so which will get the 12 volts AC, and next these 4 diodes are connected in series, so we will get 12 volts DC pulsating DC, and this capacitor is a smoothing purpose, so we will get 12 volts pure DC, which is sufficient to the battery to be charged. And this one is the main on off switch, so on and off. Okay, and next, so here we have interface the PIR sensor along with the buzzer. So these two are connected in parallel directly. Whenever the person detected, based on the motion, infrared rays from the body reflected, that will be received by the sensor, and it will given as digital output to the buzzer through this transistor board. So here using BC547 transistor, and here there are the 2 potentiometers are there, so which can use it to control the sensitivity. The first one is anti-clockwise rotation is going to be the less sensitivity, and clockwise rotation is going to be the more sensitivity. Coming to this motherboard, so this motherboard consists of a PIC16F72 microcontroller. So on this motherboard, this one is the restart switch to restart the microcontroller, and this steel plate one is a crystal oscillator, which will provide the clock pulse of 20 megahertz, which is sufficient to execute the instruction set. As the main purpose of the crystal oscillator is, so we have provided some set of instructions to the microcontroller reading input from the ZigBee and all, so that instructions will be executed based on the clocks. So one clock pulse, one instruction, like that 20 mega clock pulses from the crystal oscillator, so that it will execute 20 mega instructions per second. And next, coming to the transmitter section, so this is the USB to TTL, which will convert the TTL data received from the ZigBee and to the USB for the MATLAB understanding. So let us see the demonstration. Before switching on these kits, we need to do some initial steps. So first thing is change the hotspot name to the project 4848 without any space, without any capital letter, and a password should be 123456789. So switch on the hotspot. And also the next step is, first step is remember hotspot on with the name, and next connect your laptop to the so-called same Wi-Fi network. So you should do connect to that. So we have made a connection to that, and then open the MATLAB code. And the next, so third step is completed. And then before connecting this, if you're trying this in new laptop, you need to install this PL2303 application. When we install that, after installation, at the end it will ask for the insert this USB TTL, then you can insert, and after inserting it will ask for please restart. So you not select please restart. So then connect this to the USB slots. And then after connection was made, go to this PC. In that manage. So this purpose is to get the communication port number of this ZigBee module. So in that, go to device manager, and there will get the ports here. Right, prolific USB to serial communication. So COM3. So note down this COM3 number. Then go to the MATLAB code. Change the COM number here. So in this fifth line of the code, there we can see the says serial s equal to serial of COM3, and only you can change it. If you change this USB slot, then automatically it will be changes. So if you always connect at this position, then it will be same only always. So the next step is you can switch on the kit now, right? And after just in seconds, you will get the one more device will be connected at this slot. If it's not connected, then you need to restart the system again, means power supply off and on. So right, so we got the two devices connected, and now so you need to install one more application. I forgot to tell that, network analyzer. So this is used to get the IP address of our Wi-Fi IP camera. So in that, go to LAN scan and do the scan. So there we get the express is IP address. Note on that 192.168. So 192.168.59.204. Note on that IP address. So that the IP address we need to enter in our MATLAB code at the end. So here the I equal to IP cam. So there we need to enter the same IP address, and after that, so you can see the laser gun already on. So you can now run the code. So after these setups, so if isn't malfunction is there, if you didn't get the output properly, then you should again do the from starting onwards. So we got this GUI. So it consists of forward, backward, left, right, and gun up, gun down, video, stop. So let us see that robot controlling section. As I am present in front of this PI sensor, that's why it's continuously beeping. So now I am going to control the robot in forward direction. Stop, and backward, stop. So left turn, right turn, and the next video. So coming to that, when you click on this video, then the system will open the ESP32 camera visualization. So we are getting that. And also we can down this gun up, and gun up. So as we can see the laser details, right? Okay, right. And after that, if you exit this, you can close the GUI also. You can close the window. So later on, if you need to close the rerun the code, you need to close the MATLAB and reopen that.